Now, for example 2, what we're going to have to do here is we're going to have to get into graphing some rational functions. This is where we get the meat and potatoes. This is a good time. What we're going to have is we have this function f of x equals 4 over x squared minus 3x minus 10. And you need to go through and you need to find the 3 items that you found originally. So remember your zeros. You find that by just setting your numerator equals 0. Well, if you set 4 equals 0, that's not really possible. So since that's not true, you're not going to have any zeros. So that means your graph will not be crossing your x-axis. Maybe that means you might have an asymptote there. I don't know. Maybe. We'll see. Next thing you have to do is you have to find your VA, or horizontal asymptote. So if we do this, then that means we're going to have an x squared minus 3x minus 10 equals 0. And if you factor this, that gives you x minus 5 times x minus, plus 2 equals 0. And you set each of these equal to 0. X minus 5 equals 0 and x plus 2 equals 0. That's going to give you x equals 5 and x equals negative 2. So we're going to actually go ahead and plot in your vertical asymptote. So we're going to go back here to negative 2. Whoosh, whoosh, whoosh. And actually what's going to happen is we're going to go off this graph if we go over here and do 5. So let's go by 2's instead. So I'm going to do a little labeling here. Let's go purple. So we're going to like 0, 2, 4, 6, 8, 10, negative 2, negative 4, negative 6, negative 8, and negative 10. So if we go over and we put x equals 5, so we're here, draw in our vertical asymptote here in the middle. And then if you go to negative 2, here's your vertical asymptote for this graph. So that means now we need to find a horizontal asymptote, so your HA. So your horizontal asymptote, that is where you look at the degree of your numerator and the degree of your denominator. And if you notice the degree of your numerator is less than the degree of your denominator, which means your asymptote is at y equals 0. So if we go through here, now you're not going to draw your horizontal asymptote through the middle of 2 vertical asymptotes. What it does is it kind of just jumps out, or it kind of skips over in between your 2 verticals. So now we have our asymptotes. We don't have any zeros, so notice that we don't have any zeros here because we have an asymptote. So what we have to do is we need to make a table of values, and your table has to include at least 2 points to the left and to the right of each asymptote. So here's your x, here's your f of x. So if we have an asymptote at negative 2, we're going to go 2 points to the left. So negative 3 and a negative 4. If we put a negative 2 in here, well, that's just going to be undefined because that's where you have an asymptote. Let's put in some values here. Let's go at, how about 0? Let's put in a 2 in the middle. And we can even go 4. We'll get a little crazy here. And then if you were to put in a 5, well, that'd be undefined. So we don't really need to put in a 5, but I'm just going to show you. Undefined. And then let's go ahead and put in a 6 and an 8. So here's your table of values. So when you evaluate each function, we're going to evaluate one of them, then I'm going to put in the rest of the values, just save a little bit of time here. If you find f of negative 4, that is taking a 4 over, you take out your x, and you plug in negative 4 squared minus 3 times negative 4 minus 10. So if you evaluate this, this gives you a 4 over 16 plus 12 minus 10, which is a 4 over 18, which as a decimal is a 0.22. So if you go to the left 4, remember we're going by 2, it's 2, negative 4, up 0.22, that's barely above your asymptote, that's okay. Well, if you plug in a -3, and then you plug in your 0 and your 2, well, your 0 is actually an easy one, because if you plug a 0 in here, well, that cancels, you get a 4 over -10, which is a -4/10, or a -0.4. So if you have 0, -0.4 would be about here. So then what we're going to do is we're going to plug in the other values in your calculator, and let's see what we get. These values are what you get to fill out your table. So if you go back 3, you're going to go up a half. So remember, we are going by ones going up. So if you go back 3, so back 2, 3, up a half. Here's that. We have our 0, -0.4. If you go over 2, you go down 0.33, -0.33. And if you go to the right 4, you go down 0.67. So notice your graph is going to be actually curving back down. And then 6, you go over 6, so 2, 4, 6, up a half. And over 8, up 0.13. So here are your orange little dots. You'll notice that this graph keeps getting closer and closer as you go left to your green asymptote, never touches it. Although my pen's too big. This one keeps going up, never touches the blue. Notice you have a little bit of a curve here. So what this graph is going to do is it's going to go and it's going to curve back down and go along your horizontal asymptote. Then as you go to the right, it curves, gosh, this is horrible writing. It goes down along your asymptote there. And on the right, you're going to have your graph up here in the top right and going up like so. So that is your rational